I would like to request Mohammed Tayyab Alam sir for further proceedings. Sir.
Thank you, Dr. Vandana. Good evening, everyone. Today we have with us respected Dr. Chitra Rajgopal ma'am, Director, Center of Excellence in Process Safety and Risk Management, IIT Delhi. Chitra ma'am is a distinguished scientist, held the post of Director General in the DRDO till 2022. Before taking over this charge, she held the position of outstanding scientist and director, Center for Fire, Explosive and Environment Safety, where she has spent substantial part of her career in research and development on explosive, fire and environment safety for MOD applications, which she has played a key role in setting up and nurturing. Ma'am has 56 international and national publications with 4,827 citations, 3 book chapters, book reviews, 125 technical reports, keynote, inaugural, invited talks, and presented papers in 63 international and 55 national conferences. Ma'am's research interests include sustainable development and system analysis, environment, explosive, process, chemical and fire safety, eco-friendly and clean energy technology, environment impact assessment, safety, health and environment, disaster management, and many more. Ma'am has delivered 60 invited talks at various national and international forums. Chitra ma'am has hold 12 patents to her credit, 4 granted, 8 field to technology have been transferred to industry, 6 product, 5 software simulation models, and 2 regulations handed over to users and stakeholder. She is a member of various national and international level boards and committees. She is the recipient of several national and DRDO awards, DRDO Scientist of the Year in the year 2020, Lifetime Achievement Award by the Society for Reliability and Safety in 2019, Eminent Engineer Awards by the Institution of Engineer in 2019, and many more. Recently, ma'am has featured in the ebook on Indian Women's Achiever in STEM by CII, launched in August 2021. And ma'am has also selected for INAE Compendium on Women Engineers of India since independence as part of Government of India initiative Azadi Ka Amrit Mahotsav, India at the rate of 75. Thank you, ma'am, for accepting our invitation for Friday webinar, which has been quite popular in different social media platforms. In fact, the webinar has started its journey since 2nd October 2020 on every Friday, and we are successfully conducting this webinar under the dynamic leadership of our director, Dr. Iswarvi Basavareddy sir. With these few words, now I request Professor Dr. Chitra Rajgopal ma'am to deliver today's lecture upon integrated approach in science and technology for sustainable future. Ma'am.
Namaste, madam. Hearty congratulations. I am traveling. That's why just I got the link. My apologies not to be on time. My best wishes. Please continue, madam. Thank you.
Ma'am, please unmute your mic.
Thank you very much for inviting me for this webinar, and it will be my pleasure to share some of my thoughts and my experiences in this area. I would like to share a presentation, if I may. Can you see the slides? Can you see the slides?
No, it's not visible now, ma'am.
Not yet visible?
They're not yet visible, ma'am.
Let me try again. Can you see it now?
Yes, ma'am.
Yes, ma'am, it is visible.
Okay. And can you see the full presentation mode now?
No, ma'am, not yet.
See. Let me try again. I thought it was working earlier when we tried it. Let me see. Okay, let's go ahead and we'll see whether.
Yeah, ma'am, sure.
Yeah, okay. So once again, thank you very much for inviting me. And this is something which I'm very strongly a believer of, an integrated approach to S&T for a sustainable future. So I'm glad I had this opportunity to share my thoughts with you. As you're all aware, in recent years, we have had a number of climate-induced disasters, global warming, energy depletion, other environmental related concerns. And these have all led to a realization among all of us that there is a limit to the carrying capacity of our planet. We cannot continue business as usual without reaching a point of no return for humanity. So this has led to the emergence of the concept of sustainability. And sustainability is the key to the solution of the current problems which face us, the ecological, the economical, and the developmental problems which we face. Out of these sustainability, environmental sustainability is one pillar. And it's all about operating in a manner that respects and protects our climate and natural resources. Science and technology, I believe, can play a significant role in the development of green technologies. And these green technologies have a promising future in meeting the needs of sustainability. Now, if we can meet the needs of the present generation as well as future generations so that we can live in a clean and healthy environment, that is the goal. Can you see the next slide now?
No, ma'am, not yet.
You cannot see the next slide?
No.
Let's see. Okay, let me get back to that.
Yes, ma'am, it is visible now.
Okay. So what do we mean by sustainability and sustainable development? You are aware that long back in 1987 or so, there was a commission set up called the Brundtland Commission. And they defined in their book called The Common Future that sustainable development means meeting the needs of the present without compromising the ability of future generations to meet their own needs. Now, what do we mean by needs? Somebody would see a square, 3 square meals a day is my need. Another person would say, no, I need a good house to stay in. Another person would say, no, I need maybe a Mercedes. And a fourth person will say, I need a helicopter or a airplane to take me from this place to the other, private airplane. So the needs can keep on increasing. There is no limit to that. But needs mean something which can maintain an acceptable life standard. Now we also need to define what do we mean by limits. There is a carrying capacity of our supporting ecosystem and our resource base. And if our needs strain these limits beyond the carrying capacity, then we have a problem. So this carrying capacity is imposed by the state of our technology. Where are we in terms of technology and our social organization? So as a country progresses and the state of its technology improves and our social setups improve, then our limits also improve. That is why, in case of disasters, we find that the most vulnerable sections of society are the most impacted because their carrying capacity is low. So now let's see what sustainable development is. We have three pillars here. We have economic sustainability. That means we need a stable economy that uses energy and the resources which we have efficiently. Then we talk of social sustainability. That means society, human health, and all its related items. Then when we talk of environmental sustainability, we talk of green technology, recycling, renewable resources. In today's talk, I'll be focusing more on this pillar of sustainability. So let's see what are the drivers for a sustainable environment. Science and technology, as I said, will be one of the key drivers, and innovation. Innovation through science and technology will help us in meeting the present needs without compromising the ability of future generations to meet their own needs. We can use innovative new ideas to conserve the natural environment and resources, minimize and reduce the negative impact of our activities so that we can meet our sustainable development goals. You may have all heard of the 17 Sustainable Development Goals, which the UN enunciated in 2015. Many countries, 193 countries, including India, also supported these goals. And we have made our own national pledges so that we can meet these goals. So what is it that we can do to meet these goals? One is by reducing the amount of energy we consume, reduce the waste we produced, reduce the amount of materials we use in producing something, reduce the risk and the environmental impact, and of course the cost. So green technology is something which will help us achieve these aims. Let us see what are the essential features of a green technology. One is greenhouse gas mitigation. All of us would have heard of terms like carbon dioxide, methane, halons. All these are gases which are emitted during many of our processes and in our day-to-day living. And each of these increases, the greenhouse gas effect, because they have, they emit and radiate in the IR frequency, and therefore they trap the heat of the sun and cause global warming. So one is to reduce such emissions. The second is energy efficiency. Whatever devices we use, we must see that they are efficient. In fact, this efficiency should be in the entire cycle of energy production, transportation, and usage. Then water positive. Water positive means we use rainwater harvesting so that we add to the water table. Zero effluent discharge. That means if we can somehow reuse the effluents we generate so that there is no net discharge, and low intake of water. Minimize the use of water so that we can be water positive. And then waste minimization. How can we reduce the amount of waste which we generate? We use the 5 R's. We refuse, we reduce, reuse, repurpose, and recycle. Refuse means we refuse items which generate more waste. We reduce the amount of consumption. We reuse whatever is possible. In fact, in India, we have this long tradition of reuse of items. Repurpose means we may not be able to use that item for the same purpose, but we can use it for another purpose perhaps. Recycle, whatever has been generated can be somehow recycle it back and reuse it. So these are the 5 R's. Then low material utilization. You would have used of recycled steel, you would have heard of 3D printing. In all this, we minimize the amount of material used. And then we can look at a green supply chain. That means supply chain entirely starting from the first step to the last step. That means from the raw materials, from the using them, utilizing them, and finally their disposal. In that entire thing, we should be green. We should not be releasing GHG gases. We should not be releasing carbon dioxide. We should be carbon neutral. And then biodegradable. For example, if we use plastics, can we use biodegradable materials instead of that? So these are the kind of things which we talk of when we say green technology. Now, the other thing you would have all heard of is green energy, and one of these is hydrogen. So when we want to move towards sustainability, we use hydrogen in its various ways. One is gray hydrogen, which is from natural gas, but it leads to release of excess carbon dioxide. Blue hydrogen is when whatever carbon dioxide is released, we can capture the carbon, and there is a 90% reduction in the carbon dioxide. And green hydrogen is when we generate it by hydrolysis, and we can also integrate it with other green systems like solar energy and wind energy. So when we go towards sustainability, we use less of coal, oil, and even natural gas, and we proceed towards more beneficial like hydropower and municipal solid waste. And finally, to the most beneficial, which is green power, using wind, solar, biomass, geothermal, biogas, and low impact hydropower. You would have seen that hydropower occurs here and here. When we talk of large hydropower, there are a lot of negative impacts, both on the environment and the population. Whereas when we talk of low impact, these are those small hydropower plants which can be used with minimal impact. So let us look at what we have committed as India. We have some nationally determined contributions where we have said that in terms of solar energy, we will achieve 100 gigawatts by 2022. And I understand that already we have 107 gigawatts in place, either already in place or under, in a little while we will be having this figure. And in terms of forest cover, we have increased it tremendously to 24% in 2013, and it must be more than, I don't have the latest figures, but we are increasing this. And our long-term goal is to have 33% of all our area under forest cover. And by 2030, we will have an additional carbon sink of 2.5 to 3 billion tons of carbon dioxide equivalent. What does it actually mean? When we have forest cover, it actually absorbs, it is a carbon sink, it absorbs carbon dioxide. So more the forest cover in our land, we will be able to absorb all this carbon dioxide emitted during our different activities. Now we have also one of the world's largest renewable capacity expansion programs. And we have committed that we'll reduce our emissions intensity by 35% of our GDP by 2030. And in terms of biomass, we want to increase the biomass installed capacity to 10 gigawatts by 2022. In terms of wind energy, we are the 5th largest wind producer. And we have a target of 60 gigawatts by 2022. And in terms of clean coal policies, we want to have highly efficient supercritical technology for all our new large coal-based generating stations. So our commitments are very ambitious. And recently our Prime Minister had talked about the 5 elixirs or 5-fold strategy for India to play its part so that we can get the world on track to 1.5 degrees Celsius global warming and avoid the 2 degree Celsius, which is the danger mark. So India will have 500 gigawatts of non-fossil energy capacity by 2030. We'll meet 50% of our energy requirements with renewable energy by 2030. We will reduce our projected carbon emissions by 1 billion tons. And we will also reduce our carbon intensity by 45%. And we'll achieve net zero by 2070. This is very ambitious. Net zero means a state where our greenhouse gases, which are going into the atmosphere, are balanced by an equal removal out of the atmosphere. And we have 17% of the world's population, but we contribute only 5% of the emissions. India, we compared to 15.5 tons by US and 12.5 tons by Russia, we emitted 1.9 tons of carbon dioxide per head population in 2019. So I'll talk a little bit about my previous organization, what we had done for sustainable environment, and then I'll talk about my present uh, center of excellence and what we do there. So let me tell you about some of our eco-friendly waste treatment and disposal technologies, what we did for site remediation, some eco-friendly materials, how we did resource minimization, what we did for climate change mitigation, and capacity building. So these were some of our eco-friendly technologies for waste management. We set up pilot plants to treat various kinds of wastes using adsorptive removal, using stabilization of heavy metals, polymers, and other kind of wastes, and also electrochemical treatment of contaminated effluents. All these were set up at pilot plant level and demonstrated to the industry. We also had advanced oxidation plants for treatment of certain critical wastes. And we could achieve zero discharge, recyclable water, and an eco-friendly technology. Then we also did some remediation of contaminated sites. And this is called green remediation, where we consider all the environmental effects of the remedy and incorporate options to maximize the net environmental benefit of all our cleanup actions. Right? At the core are energy, air, water, land, and ecosystems, and waste and materials. So the significance of site management is that all the procedures which are followed minimize the environmental damage, and we can use the site for future use. So let me now talk about various remediation practices. Phytoremediation, which means using plants to remediate the soil, microbial remediation, and micro-stimulated phytoremediation. So we use certain biofuel crops, and these we found could degrade some of the contaminants. And we also used cultures, various cultures for biotransformation. So these were some of the studies we did. Then we also developed eco-friendly polymers like photodegradable polyethylene. We found that when our soldiers who are stationed at high altitudes, they use food packaging, and this food packaging litters the ground and it cannot be degraded by bacteria under those extremely cold conditions. But we found that there is a lot of UV component of sunlight, and this UV component of sunlight can degrade polyethylene provided we add certain oxidants when we are manufacturing the polyethylene. So that is what we did. And we found that with this, the UV part of sunlight was able to degrade it to such an extent that we ended up in powdered PE, which was then biodegradable. Similar, and this we found was cost effective. It was whatever we could add was compatible with the polymer. And we got good properties like clarity of the film, and we could use it for food, and it was non-toxic. Then if we want to reduce material which we use, so that when we use any material, over a period of time, it degrades. Instead of removing that and using a new material, we've thought how to heal that material, how to repair it, how to introduce a self-healing functionality so that we can reduce the amount of resources required. So this is something where in case of a damage, the crack which happens in that material, the crack propagates and ruptures some microcapsules which we put inside, which contain a healant. And this fills the crack and gets cured and then closes the crack. So this is something we did using various materials so that we introduce, as I said, a self-healing functionality, and we don't have to replace that material. Then we also did some work on recycling of various kinds of waste like PET wastes and made them into useful materials like metal organic frameworks, polyurethane foams. These metal organic frameworks can be used for hydrogen storage. I'll come to that a bit later, why that is useful. Then we also did some work on climate change mitigation and energy security. We, from bioethanol, which is a carbon neutral source, we generated clean fuel hydrogen. So hydrogen is a clean burning fuel. It has high combustion efficiency. It meets our national goals in cutting carbon emissions and reduces global warming. So we used bioethanol here and used various types of catalysts to generate hydrogen, which can then be used in a fuel cell to produce electricity. Then you also know that halogens, many of you would have heard that halogens were used for fire suppression. But halogens also deplete the ozone layer, and they also have a global warming potential. So we came up with some alternatives for fire suppression, like heptafluoropropane, water mist. Water mist is a very clean agent for fire suppression. This is small mist of water, less than 50 to 100 microns in size. And this can be used for various kinds of fires instead of using halon. Then we also came out with various chemical powders to extinguish fire rather than halons. We came out with a gel, which is used for extinguishing fire. Generally, what happens if you use water, 90% of the water goes waste as runoff. Simply runs off. It isn't used for fighting the fire, it just runs away. And then it goes off into vaporization also. But if you use gel, what happens is it covers, it swells in the water, and it prevents the water from running off or evaporating too quickly from the burning objects. It extinguishes the fire and prevents it from spreading. And it also coats the combustible material so that the material is no longer exposed to oxygen, and then the fire is quenched. So these are some of the ways in which we came out with firefighting materials. Then I wanted to share with you, how are we doing for time? We have another 10 minutes or more?
Yes, ma'am.
Yeah.
We do.
Okay. So I just wanted to share some potential energy sources of the future. It's a really exciting time to be alive. If you can, you watch this YouTube video. I have given you the link here. What it says is we have a front row seat to the only known transformation of a world which is powered by dirty fossil fuels to a planet that gets its energy from renewable clean sources. It's happening just once, and it's happening right now. So these are some of the exciting things which are on the horizon. Giant solar farms in space, which can collect high-intensity, uninterrupted solar radiation. And it converts it into a laser beam or microwave and wirelessly beamed to Earth. Human power. We know that even very small movements of ours, that movement, we can harvest power from that using tiny electronic circuits. And it can be used to charge a mobile phone, even if it rustles in our pocket or in our handbag. Then hydrogen, of course, I already talked of hydrogen. That is one of the most abundant sources of energy, but it is available only as a compound like water. So you have to separate the hydrogen and store it, which is a bit expensive, but we are working towards it. Once we separate it, then hydrogen can be used in fuel cells where it will get converted into electricity and we can run cars, or we can fly the aeroplane, or we can use it for stationary uses as well. Then geothermal heat, you would have heard of. There are many countries like Iceland where they use it in a very major way for their electricity. So from the depths of the earth, we can take this energy and use it for various uses. And then solar windows for a city of the future. If you have used this quantum dot solar cell technology, you can use highly efficient solar panels to double the transparent windows. Anybody who sees these windows won't be able to make out that they are actually solar panels. So every sun-exposed window can become a power generator. So you have a glass skyscraper, which instead of using energy, becomes a source of power for the entire building. Then you have biofuels. You have heard of first generation biofuels. These came into a lot of controversy because they use the same crop which is used as food for people. So we don't want to use that. The second generation biofuels are agro-wastes, like when we produce bioethanol from agro-waste. Now let's look at third generation biofuels, where algae, which are found in water, their natural oil content is more than 50%. So that can be easily extracted and processed. Can be grown quickly. We don't need farmland or fresh water. And it can also convert wastewater into pure water. So this is third generation biofuel. Then flying wind farms. This sounds very exciting. You know, this is something here. It's like a bird. Is it a bird? Is it a plane? No, it's a huge inflatable wind turbine. So these flying wind farms are deployed where traditional wind farms are not possible. They bring energy and in addition maybe internet to remote towns. So this is again a wind turbine with a rotor. It is supported in the air without a tower. So we can benefit in many ways. And we can avoid the expense of a tower construction or the need of other mechanical equipment. Then novel energy storage and transfer mechanisms. You know, in Stockholm, they have a road which has been designed to transfer energy to specially designed cars and trucks from an electrified track in the road surface. And there is a movable arm beneath the vehicle which detects when the rail is near and lowers to begin charging. Isn't that exciting? Perhaps in a few years, we will have such roads even in our country. So these are some novel energy storage and transfer mechanisms. Then we also have nanoparticles which are coated with organic dyes. And this can catch near infrared light, which is missed by solar cells, and convert it to function as antennas and re-emit the light in visible light spectrum. So this again meets our energy security needs. And as far as food security is concerned, we come out with high tolerance crops. So researchers have discovered how a protein in the plant roots controls the uptake of minerals in water so that it improves the tolerance of agricultural crops to climate change and reduces the need for chemical fertilizers. Then this is a decision support system which can be used for efficient waste collection in smart cities. So what happens is we use Internet of Things surveillance systems, which are assistive technologies for high quality service and waste collection. So they use RFID, sensors, cameras. They are all incorporated into the ITS and surveillance system for efficient waste collection. So this is one system which all of us can think of. And it incorporates a model so that data is shared between the truck drivers on real time so that they can perform waste collection and dynamic route optimization. These are microbial fuel cells for wastewater treatment and energy generation, where you can use our wastewater from the municipal sources or agricultural waste, industrial waste. All this can be converted using microbes, and we can generate electricity. So this can be integrated into our existing wastewater treatment systems to enhance energy, water, and nutrient resource recovery. Now let me conclude by talking a little bit about the Center of Excellence we just created in IIT Delhi. This is unique in the sense that this has been set up for the purposes of process safety, risk management in industry, as well as looking at the entire hydrogen value chain. So we have IIT Delhi as the academic partner, NIRA as the industry partner, and GEXCON Norway as a knowledge partner. And our goals are to develop human capital through education and training, using advanced tools, to conduct R&D in process safety and in the entire value chain of green hydrogen, production, storage, transportation, and application, and also provide consultancy and advisory to industries, government, and public sector units. So our domain areas are process safety, risk management, hydrogen safety, and green hydrogen. So our GEXCON, that is a knowledge partner, along with them, we'll be using this expertise in hydrogen safety for assistance in conceptual phase of any hydrogen plant, optimization of ventilation gas detection, modeling of accident events, dispersion, explosions, fires, design of structures, how to withstand accidents. So this will be done we'll be using this expertise for the entire value chain of hydrogen production, storage, transport, distribution, mobility. So these are some of the can be offered: risk analysis, modeling of accidental events, structural response, and testing. And these are some of the methods we use. So let me conclude by saying that we have not inherited the earth from our ancestors, we have borrowed it from our children. And I think if you go to this site, you'll be able to see some of the incredible eco-friendly innovations which are now coming up to save the earth for our children. Thank you.
Thank you so much, ma'am. Thank you for delivering such an interesting lecture. I would like to take few questions that are in our comment box, ma'am.
Yeah.
Ma'am, you just mentioned about alternative energy resources. So where do you see India in next 10 to 20 years in the area of energy security?
Actually, you would have heard about the recent commitments which we have made. They are indeed very ambitious commitments, but we have also achieved a very high level of where we are now using renewable energy. We have come out with solar energy. We have a solar energy alliance which have been set up recently. And in terms of how many gigawatts of installed capacity we have, both in terms of wind, in terms of solar energy, and in terms of hydropower, small hydropower, we are setting up. And now hydrogen is going to be the hydrogen roadmap which our company is coming out with. It is again a very ambitious roadmap, but a lot is being done in all sectors of the economy, including the oil and gas sector, the traditional sectors, energy sector. They are one of the main sectors. And in addition, steel, cement, fertilizers, all these sectors, they are going to switch over in a major way to so that they can adapt to the new hydrogen economy. Then there is a lot of role for researchers in the R&D institutions. They have to come out with innovations to address the various challenges here. Also academia. So all these people have to come together, industry, academia, researchers, and I'm sure that we will be able to meet goals which we have set for ourselves.
Yes, ma'am. Sure. Together we can make the difference.
Yes.
On the occasion of National Science Day that occurs every year on 28th February, and on this year's theme of National Science Day, integrated approach in science and technology for sustainable future, it was quite a delightful experience to listen Professor Dr. Chitra Rajgopal ma'am on the topic. On behalf of Morarji Desai National Institute of Yoga and all our viewers, I would like to express my gratitude to you, ma'am, for accepting our invitation and delivering such an informative and insightful lecture. Thank you so much, ma'am, for being with us today. Thank you so much.
Thank you. In fact, I would like to share with you, I'm one of your older students of the Yoga Institute.
Yes, ma'am, I know that. I would also like to thank Director of Morarji Desai National Institute of Yoga, Dr. I.V. Baswa Reddy sir, for being the guiding force behind these kind of programs. Thank you so much, sir. And I would also like to thank Communication and Documentation Officer of MDNIY, Mohammad Tayyab Alam sir, for his help and support, and all the technical team for their help, and all the viewers for joining us today. Now let us end the program with Shanti Part. सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामया सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् मा कश्चित् दुःखभाग् भवेत् Om Shanti, Shanti, Shanti. Thank you so much, ma'am. Thank you once again.
Thank you. It was a pleasure interacting with you.